Hey guys, have you ever played Taboo? I love that game. I'm going to play with you right now, okay? I can't say the words that are listed here. So, okay, ready, go. It's in the shape of a square, and you put an infant in it, and there are toys in it, and yes, Jackie just got it. Playpen, woo woo. All right, so anyways, Jonas, I love that game. Okay, we're going to do some theorems based on congruent triangles. The next couple sections are going to be fun. Page 124 and 125, you have to put all these notes in your notebook. There's quite a few of them today. So basically there's not a lot of explanation, there's just a lot of notes. Theorem 3.1 says, and in isosceles, it's the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So that's a fun little thing that we're going to learn there. So here's an isosceles triangle. I want you to write all this in your notebook. This triangle, the two legs, so this is called the leg and this is called the leg of an isosceles triangle. This is the vertex angle, and these two angles are the base angles. This here is the base. So this is your isosceles triangle, legs, base angles, vertex angles. What this theorem says is if these two sides are the same, so let's say they're just both 5, then let's say that's 63, that's going to be 63 too. Okay, so the angles opposite the legs, the base angles opposite the legs of an isosceles triangle are equal. Corollary 1 says an equilateral triangle is also equiangular, and we can also take the reverse of that. An equiangular triangle is also equilateral. So if you have a triangle that has all the same sides that are equal, okay, so let's say that's 6, and that's 6, then let's say this is, I'm just going to say 60 degrees because it's equiangular and equilateral. If that's 60, that's going to be 60, that's going to be 60. If you notice, across opposite sides and angles are always equal in measure, okay? So, corollary 2, an equilateral triangle has 3 60-degree angles, so I just showed you that. All the angles in an equilateral triangle are 60 degrees. Not so much for all the sides. All the sides are equal, but they don't have to be the same length as, I could draw a bigger equilateral triangle, a smaller one. The lengths of the sides would be different, but the angles will always be 60 degrees. Corollary 3, the bisector of the vertex of an isosceles triangle is perpendicular to the base at its midpoint. So let me draw that for you. Here's a triangle. Okay, it's isosceles. Okay, this is your vertex angle. If I draw a bisector, that means I'm going to bisect this angle. So when I draw that down, we know that that means that these two angles are going to be congruent. Also means that, bang, this is the midpoint of this segment right here. Okay, so the bisector of the vertex of an isosceles triangle is perpendicular to the base at its midpoint. So that's going to be a 90-degree angle. That's your midpoint. These two are going to be equal, okay? So you might have to use that in a proof someday. Theorem 3.2 says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So it's kind of like the opposite of what we just said, but let's go back over to this example. These two angles are congruent. They're both 63 degrees. So that means the sides opposite them are going to be the same length. So that would be 5 and that would be 5 or whatever. Okay, there is also a proof on page 125. I would like you to put that proof in your notebook. So we've got lots of writing to do, but this stuff is fun and you're going to like it. Keyword for today is taboo. See you later.